Hello, this is the beginning of college algebra, and we are going to be starting the beginning of the course here. This is Professor Berru-licon, or Professor B, and we're going to start out with just some background knowledge, prior knowledge to the actual course material. The beginning of the notes for Unit 1, I'm just going to be giving you a lot of resources. There's not going to be a lot of problems or anything like that in these first several pages. Really all of part 1, all of this first video, for the most part, aside from a few problems at the end, will really just be resources for you to come back to when needed. So since we don't have a formal textbook and we are mostly using notes and the work we do in class and homework, I wanted to include these resources for you. So when we're talking about numbers in general, there are a number of different terms you're going to hear, and they're referring to different kinds of numbers. The most basic set of numbers that you can talk about are called the natural numbers. The natural numbers are also called the counting numbers, and if you were counting, for example, people in a room, you would start with 1, and then 2, and then 3, and then 4, and so on. You wouldn't start with 0, and you wouldn't count half people. You would just be counting the number of items or the number of people. So those are the counting numbers or the natural numbers. The whole numbers is the exact same set of numbers, but it also includes 0. So that's the only difference between these two, is the natural numbers, it's just 1, 2, 3, 4, so on, all the way to infinity. No negatives, no fractions, no decimals, nothing like that. And then the whole numbers is all of those, and then it also includes 0. Integers are all of the whole numbers, and then it also includes the negatives. So still no fractions, no decimals or anything like that, but it includes the negative numbers as well. Okay. Then we have what are called rational numbers, and these are numbers that can be written as a ratio or as a fraction. So that includes positive and negative fractions. That includes what is called a terminating decimal, meaning the decimal ends, it doesn't go on forever. It also includes repeating decimals, so any decimal that repeats the same pattern. And then it includes negative numbers, whole numbers, all of those as well. Okay. And then we have what are called irrational numbers. And this is the set of numbers that is written as a decimal but never ends and doesn't have any pattern. So probably the most famous irrational number you may have heard of is pi. We see that when we're working with circles. Another irrational number we will be working with this semester is e. And then square roots of anything that's not a perfect square. Those are all irrational numbers as well. They are decimals that go on forever that don't have any pattern. All of these numbers that we just went over are classified as what are called real numbers. So these are all included in real numbers. And then separate from real numbers, we have what are called imaginary numbers. We will see those pretty soon this semester, and those numbers will have an I on them. And we'll talk about those a little bit more when we get there. I is the definition of the square root of -1. And then all types of numbers can be classified as complex numbers. So the way these all relate to each other, the natural numbers are part of the whole numbers. The whole numbers are part of integers. Integers are part of rational numbers. Rational numbers are part of real numbers. Rational numbers and irrational numbers are separate from one another, but they are both real numbers. And then imaginary numbers are separate. All of these are complex numbers. Okay. We're going to look at some terms here. And some of these terms are things we will be using very soon. Some of these terms are terms that it'll be a while before we actually use them. So we have a set. That's a group of numbers or items that fit a certain criteria and can be defined clearly or clearly defined. If we're in a room with a group of people, I could talk about the set of people who are all wearing the color red, or the set of people who all have brown hair. You can classify groups with certain criteria. If I'm talking about a set of numbers, if I wanted to talk about all even numbers, that would be a set of numbers. or all numbers less than 5. So there's a number of different ways we can define a set based on certain criteria. An element is each member of the set. So again, going back to a room of people who are and they're looking at the set of people who are wearing red. If I talk about one certain person wearing red, that would be one element of the set. We can list out a set of numbers using what's called roster method. That's just listing them out. Set builder notation, which looks like this, and the way you would read this is X, and this line right here means such that, and then a description of X. And we will also look at what is called interval notation, and we'll talk about that in just a second lower on this page. We also can look at sets in their relationships to other sets. So we can look at the intersection of sets and the union of sets. And this is the notation you would use for each of those. And this little upside down U here is the intersection. It means what these two sets have in common. The union of these two sets is just combining the two sets together. So bringing all the elements together. So for example, if we were talking about the two examples I gave of people in a room, if I'm talking about all the people who are wearing red or all the people who have brown hair, then the intersection of sets would be all of the people who have brown hair and are wearing red. The union of those sets would be all the people who either have brown hair or are wearing red brought together. More terms. Absolute value is defined as the distance from 0. A distance can't be negative, so that's always going to give you a positive value. We have opposite and additive inverses. Those are two numbers whose sum is 0. So for example, 5 and -5. Those are opposites or additive inverses. Reciprocals or multiplicative inverses are two numbers whose product is 1. So that would be like 5 and 1/5. You multiply those and it gets 1. A term is just a number, a variable, or the product of a number and a variable. The coefficient would, in this kind of example here, if I have -3x squared, -3 is the coefficient. And then like terms are terms that have the exact same variable components. So the same variable and the same exponents. So for example, if I have x squared minus 3x plus 4y minus 6x squared, the only like terms here are the x squareds. Even though this term has an x, they don't have the same exponent. Even though these two have the same exponent, 1, they don't have the same variable. These two are the only like terms that could be combined. And looking at this next part here, this is really just something probably we're going to reference back to more in a little bit. But basically, if I am looking at a number line or looking at an interval or an inequality, this is kind of a translation among how to say it in words, what the graph would look like, what it would look like written in interval notation, and what the inequality would be. We're going to practice this a lot more later on, so this is really more just a reference for you to come back to if needed. Some more terms. I'm not going to go through each of these. We're probably not going to use these all that much, but if you ever saw one of these terms, this is just really a resource for you to come back to and understand what it means. In our course, with all of the material you'll see, we will have word problems. It will be a very regular thing. Definitely don't feel intimidated as much as you can by word problems. Oftentimes the math you're doing in a word problem is easier because the challenge is dealing with all of the words. So these are often problems that are easier mathematically than other topics we'll look at. So these are just some strategies that you can use and look back at in working with word problems. I'm not going to read through all of them in this video because you have them in front of you and you can read through them. Here I have some shapes and formulas, so area and perimeter, and then more shapes on the next page and more formulas, what those shapes are called. Again, really just a resource for you to come back to when you need it. Now, this next page will be helpful in translating phrases. So sometimes you'll hear a problem written out in words and you need to turn it into an equation with symbols. So for example, if it says the sum of x and y, what that means is x plus y. Or if it says 7 less than t, then that would be t minus 7. So this is, again, a good resource for you to come back to when needed. At the bottom of this page, we see some terms referring to consecutive integers, consecutive even integers, consecutive odd integers. And sometimes you might see a word problem that asks you to turn that phrase into an algebraic expression. So I'm going to show you how to do that. Now, consecutive integers are numbers that are one right after the next. So that would be like 1, 2, 3, 4, 5. They're one right after the next. And we can represent that with n, and let n just be any number. And the next number after n would be n plus 1. The one after that would be n plus 2, n plus 3, and so on. So let's say n was 5. This would be 5. 5 plus 1 would be 6. 5 plus 2 would be 7. 5 plus 3 would be 8, and so on. Now, consecutive even integers, we need to make sure each piece represents an even number. So if n can be anything, any number multiplied by 2 will definitely be even. So even if n is 5 times 2 would be 10. If n is even already, let's say it's 4, 4 times 2 is 8. That's still an even number. The next even number would be 2n plus 2. And the one after that would be 2n plus 4, and so on. So for example, if n was 4, 4 times 2 is 8, 4 times 2 is 8, plus 2 is 10, so 8, 10, 8 plus 4 is 12, 12, so 8, 10, 12, those are consecutive even numbers. And similarly, if we want to make sure that we have odd integers that are consecutive, well, if 2n is definitely even, after an even number, it's always an odd number. So 2n plus 1 is definitely going to be odd. So let's say, for example, n is 4. 4 times 2 would be 8, plus 1 would be 9. That's odd. What if n is 5? 5 times 2 is 10, plus 1 is 11. That's odd. So consecutive odd integers would be 2n plus 1, 2n plus 3, 2n plus, n plus 5, and so on. So again, this is really just a resource for you to come back to as needed, and you can use this on homework to help you and whatnot. So we're going to look at a word problem now. It says a hotel charges $140 per night. In addition, there is a one-time parking fee of $40. Write a formula to represent the total cost C for n nights in the hotel. So part A, we are asked to write a formula for the cost of the hotel in terms of the number of nights. Well, we have a one-time parking fee of $40, so we know we're going to have to pay $40. And then we know it's going to be $149 per night. So if we have $149 per night, then we don't know how many nights we're staying, or we want to write a general formula. That would be plus 149 times the number of nights. So that's all part A is asking for, is a formula. Part B says determine the cost to stay in the hotel for 2 nights. So that would be the cost, $40 plus 149 times 2. Well, 149 times 2 is 298. 298 plus 40 is 348, or 338. Okay. So that's basically it for that word problem. Again, the math there wasn't all of that challenging. It was really just deciphering what the question was asking. Okay. So let's go on to the next page. And here we're going to be looking at inequalities. and looking at order of operations and practicing some of that. So, inequalities, that's what these symbols here are called. This is less than or equal to, that's what the little line underneath it means, greater than or equal to, less than or greater than. And we are going to be also using some brackets, parentheses, closed dots, and open dots. These three go together. If you're working with inequalities with the line underneath it, you're going to use closed dots and brackets. If you have an inequality that does not have the line underneath it, you'll use open dots and parentheses. And that'll make a little bit more sense in a little bit when we start working with inequalities. Now, sometime back, maybe in elementary school, you probably learned PEMDAS, or order of operations. Some teachers, rather than PEMDAS, title it GEMDAS. Either way is perfectly fine. P stands for parentheses. E is for exponents. M is for multiplication. D is for division. A is for addition. And S is for subtraction. And this is the order things need to be done in. So parentheses are first. You want to take care of what's inside the parentheses first. Then you apply any exponents, then multiplication and division, and addition and subtraction. Now these two and these two are actually the same. Multiplication and division can be interchangeable as far as the order. They're the same kind of operation. Addition and subtraction are the same as well. They're the same kind of operation. They can be interchanged as well. So we're going to practice a couple of those problems, and I think that will take us to the end of our first video. So these ask us to evaluate, and so I need to follow the order of operations we just went over. So any parentheses here, I have a set of parentheses right here. I need to evaluate what's inside first. Now, even though there aren't actually parentheses here, you can kind of consider the top being grouped and the bottom being grouped. So I can actually evaluate those as well. So on the top there, I have 4 plus 8, and that's 12. And on the bottom, 2 plus 1 is 3, minus, and in parentheses here, 1 minus 3 is negative 2 to the 5th power, plus the cube root of negative 8. From there, I'm running out of room here, I'm going to move over here. 12 divided by 3, well, that would be 4. Minus negative, C students do, is they will go straight to saying a negative times a negative is a positive, but I need to apply exponents before I do multiplication. Remember, exponents are before multiplication, so I need to apply this exponent before I do that multiplication. Negative 2 to the 5th power is negative 32, so minus negative 32, plus negative 8, and the cube root of that is actually negative 2. So I can go ahead and evaluate that because roots are also like exponents. So we could say exponents and roots. Now all I have left is addition and subtraction. So a negative times a negative would be a positive. 4 plus 32 is 36. Plus negative 2 is the same thing as minus 2, and that would be 34. Let's do the next one, and that'll be the end of our first video here. Here I have multiple sets of grouping symbols, so we want to work on the most inside first. So the most inside set of parentheses I have here is right here, and then working outwards, I have a set of brackets here. So 2 minus 5 is negative 3 squared, and then just kind of bringing everything else down here. This should not be here yet. That parenthesis, I have that 2. And I'm really just bringing the rest of this down for now. I'm working on the most inside part first. Negative 3, there's nothing inside the parentheses, but I do need to apply that exponent before I multiply here. So negative 3 squared is 9 times negative 2. And again, just bringing the rest of this down because I can't do anything about anything outside of these brackets yet. 4 minus 2 times 9. Well, the multiplication needs to happen before this subtraction. Multiplication is before subtraction. So 2 times 9 is 18. So what I have here is 4 minus 18 And 4 minus 18 is negative 14. So 4 minus 3 brackets, and I just have negative 14 inside there, divided by 2. Now here's where sometimes students aren't sure what order to do things here, because I have multiplication and division. And here's the answer. It really doesn't matter. I could do 3 times negative 14 and then divide by 2. Or I could do 14 divided by 2 and then multiply that times 3. Either way is going to give you the same answer. If I do 14 divided by 2, that's negative 7. Negative 14 divided by 2 is negative 7. So 4 minus 3, and that'll be times negative 7. Negative 3 times negative 7 is 21. And a negative times a negative is a positive. So 4 plus 21 is 25. Okay. And we'll go ahead and end our first video here, and we'll pick up with the union and intersection of sets in video 2.